Hey guys, welcome back to my YouTube channel. So in this class, we are going to continue our extension on the non-uniformly doped N-type N-type semiconductor. So we know that this is the representation that we used to follow for the non-uniformly doped semiconductors, and the plus and the electron outside, which is indicating that it is an N-type. So this is a non-uniformly doped N-type. So we can clearly say there will be some kind of inbuilt potential that will be built. Some inbuilt potential as well as inbuilt electric field will be there, but the net current will be equal to 0, that we already discussed in the charge neutrality condition. So if you guys have any doubt, you can go and watch that one. So because of this input electric field variation, there will be electric field produced in this direction. Then you guys can answer from which direction the voltage and electric field will be. So this is the electric field will be pointing from positive to negative. So the variation, electric field variation, is from this direction to this direction. So we can clearly state that the energy band will be forming in variation will be happen in this direction. If the electric field is happening in this direction, then electric field will be, the potential will be exactly opposite to that of that. So we can get into this one. So this is how the voltage variation will be. So now let's get into how the variation of electric energy band will be looking like. Okay. So here you can see there will be inbuilt potential electric field is happening, inbuilt voltage as well as inbuilt electric field is created. But this will not be enough to produce the external current field, because based upon this one, the equal amount of electron holes will transfer in opposite direction, and the I net will be always equal to 0, because here there is no external disturbance is happening, right? So there will be only change in the values and the energy level. So this is EC and this is EV. So this will change, but similar to this, the EI will also be changing. But the thing is that the EFN, the Fermi energy level of the donor atom, will never change. Sorry. As you see, there will be no change in the this thing. This is because there will be no movement, so there will be no current. So EFN. So dFn divided by dx, which is equal to 0. Because of this, I will also be equal to 0. But these things will be get changed. These things variation is because of the inbuilt potential change. I think it's understood for you guys. If you guys have any doubt, please ping in the comment section. So this is what the thing. So I hope it is understood in how the non-uniformly doped N-type semiconductor without electric field which will be acting. So if there is an external potential, then the previous class we saw, right? So similar to this only, there will be observation. Even the slope will be more steeper. So that's what the changes. So I hope it's understood for the N-type. So let's start with the P-type. So our fifth thing is the uniformly doped P-type. Let's compare it comparatively. So here let's take the semiconductor. So as we know, this is uniformly doped. So this will be similar to that. So let me drag and drop another one. So let's take a graph. This graph is the energy band variation across the distance. This is X, this is E in electron volts. So as you guys know, there will be no change in the energy bands. So this will be EV and this will be EC. Everything is similar. This is EFI, intrinsic energy level. And the change is that because it is an P-type, so the energy band will lie exactly in this direction. Okay, so this is EFP. this is EV, and this is EC, this is EFI. So there will be no change as there is no external difference or external trigger, so there will be no current movement. So voltage will also be constant. So let's take the sixth one. So this is also the non-uniformly doped thing, the uniformly doped thing only, but with the external supply. So let's take uniformly doped p-type. So this is also similar. Okay, so let's give a bias. Okay, so let's take the bias of negative positive. So here this negative, this is positive. So if we apply it, then the electric field variation will be in this direction. The electric field will be pointing to this direction. Okay, I hope you guys understood. This is from positive to negative, so electric field will be in this direction. So the holes will be moving in. So the holes will be moving in this section. It is the majority charge carrier. Electrons will move in the opposite direction, and the net current will be in this direction. Okay. So net current will be in this direction. This is holes, and this is electrons, and this is I current. So let's see how it is affecting the energy band structure. I hope you guys can able to draw it. So please pause the video and try to draw it. So if you guys able to achieve it, please ping in the comment section that you guys are able to draw it. Then I will be happy on this. So the variation will be in this direction because it is here positive and negative as we start on shortcut, right? So drifting will be in this direction. Okay. So this is EC, this is EV, this is EFI, and this is EFP. Okay. As you can see, there is a change. This change is because of the external supply that we have produced. So we know that the voltage will be in the exact opposite direction to that of the electric field. We need to note the point that this change is because of this electric field external supply voltage only. So that change will be quite opposite, just opposite to that of this. So this is sloped in this direction. This is the slope will be here. It is positive, but here if you see the slope is negative. This is what the change is. So it is positive slope and here it is negative slope. So that is what the observation that we have to remember. So this is with respect to p-type, which is with the uniformly doped. So let's take a study that. Let's take a uniformly doped thing. So non-uniformly doped p-type. So this is the last one. From this we can conclude the understanding on the variation of the energy band with respect to the doping profiles. We have seen plenty of cases in charge neutrality also we gone through this kind of observation, and here also we have gone through. So these kind of doping profile understanding need to be there for you guys to understand the semiconductor structure. So as we draw for the n type, we can draw for the p type also. Because of the non-uniformity profile doping, there will be the a diffusion of charge carrier. So we can state directly there will be a net movement of current. There is electric field will be pointing to this direction. So this is electric field direction. So because of this one, the every charge carrier will be drifting to this one. So EF, EP and everything will be shifted in this direction. This is EFI. But you can clearly say that there will be no change in the EFN because there is no external supplies produced. I hope it is understood for you guys. So this is EV, this is EFP, EFI and EC. Okay, this is X, this is E, and this is the also electric field. This is EV, this is energy gap, this is electric field. It's a quite difference. So I net will be equal to 0 as we know, that is why, because. Okay, so as we can clearly state that there is no change in the Fermi level of the acceptor atom p type, so there will be no current produced. Okay, I hope it's understood for you guys. So we can clearly state that how the charge profile will varies for different things is, and how the electric field and the voltage that is applied or inbuilt voltage field that is created, everything that is how it is changing. So we have shown six profiles, six things. First one is the n-type non-uniform dope. As you see, there is no changes in the Fermi level and energy band diagrams. So in the second one, we have gone through n-type with some positive biases. So in the based upon the bias, there is a change in the electric field and the Fermi level direction. And then we saw another one thing where the polarity is reversed. You can clearly see that the electric field are aligned in opposite direction to that of previous one. And therefore, when we come into non-uniformly doped n-type, so that you can clearly state there is a change in EC, EV, everything, but because of the no extra voltage applied, so the Fermi level of the donor atom or acceptor atom will not be changing in these cases. So then the fifth one is uniformly doped p type. So where we have seen two types with a no external supply and one with the external supply, and you can see how the doping profiles are changed and varied. So in the last one we have gone through non-uniformly doped p type. So where also we can clearly say that the Fermi level of the acceptor atom will not be changed because there is no external supply. I hope it is very clear for you guys. If you guys have any doubt, please ping in the comment section so that I will clear you doubt. So these kind of things are very much important for you guys to proceed to the further next level. From this point, if you guys are clearly able to understand everything, I'm pretty sure that you are having a good profile of knowledge in the semiconductor physics. So that will help you guys in finding learning everything like microprocessor, microcontroller, our next topic like analog devices, electrical circuits, network theory also. It will be quite helpful for you guys. So I hope it is understood for you guys. So let's stay tuned for the next lectures. Thank you. Like, share and subscribe the channel.